The most common question asked of us at Porcelato Engineering is how much is it going to cost? The second most common question asked is what is the safest usable RPM range? We always answer that question by referring to the most common application, which is stock, and that we don't suggest that customers exceed the 4,000 RPM limit built into the stock engine. Now, with a slightly modified engine, you're limited by the clutches. The clutches state clearly on them that you can't exceed 5,000 RPM. But what is the safest usable RPM range without a catastrophic failure in an extensively modified engine? Well, we're going to find out today. I know some people might think it's a little bit wasteful to blow up an engine, a perfectly good engine, but this is a bit of a safety concern as well. I mean, you're sitting on these engines and you should know where the limits are. Now today we're going to use an FE290 engine. Well, it started as an FE290. This is a big bore engine. It uses an FE350 piston. The engine has the oil feeds for the link assemblies for the counterbalance welded up, and the counterbalance is removed. Has a 35 millimeter intake valve, 6.5 millimeter stems, 31 millimeter exhaust. It uses the Mikuni carburetor and the adapter that we manufacture. Has one of our custom camshafts, the 301 lift, 310 degrees of advertised duration. These things live happily on our dyno to the limits of our pump, which is about 4,500 RPM. They make 17 horsepower. Today we're going to take it out to the wash pit. We're going to remove the belt. We're going to let the engine free rev, and we're going to see when it all fails. So I hope you learned something from the video, and then we'll do a little bit of a failure analysis at the conclusion of the video to show you what actually went bad and how bad. So I hope you enjoy the video. We're just going to just give you a quick dyno run of this baby to let you know that it is a perfectly good working engine, and then we'll make our way out to the wash pit and see what it can take. Well, in that last shot, you saw the something fail, looked like the rod, so we're going to do a little autopsy here. We've got the side cover off, and we learned what failed now. Basically, you know, as I mentioned, in production engines, we're only a couple of tenths piston wall. In this big bore engine, it's set up the same way. So what it looks like happened is over those repeated attempts to overspeed the engine, we put a whole bunch of temperature in the top end or the piston area. What that did was it eliminated our piston wall, and it started to drag the liner back down. We don't see this in a standard operation, but that big liner we put in for the FE350 has been dragged down, and we can feel where the con rods were actually smacking the bottom of the liner that we put in, or the cylinder sleeve. So it basically, it's what caused this rod failure. It's just the rod, you know, repeated contact with the bottom of that sleeve. So we learned a little something there, but it wasn't as dramatic as we thought it would be. But anyways, the clutches survived and the flywheel survived. And anyways, thanks for watching. Bye for now.